Hi, I'm Zhen Jiang. I will now present our paper, General Instance Distillation for Object Detection. In recent years, knowledge distillation has been proved to be an effective solution for model compression, which is transfers the knowledge of large model to small model, thereby improving the performance of the small model. However, different from image classification, most detection tasks need to deal with the extremely unbalanced ratio of positive and negative instances. Some previous methods address this problem by distilling the positive and negative instances in a certain proportion sampled by RPN, and the other method further proposed to only distill the near ground truth area. Nevertheless, the ratio between the positive and negative instances need to be meticulously designed, and distilling only GT-related area may ignore the potential informative area in the background. This observation leads us to our first contribution that we define general instance, aka GI, as a distillation target. GI are some discriminative instances between the student and teacher. Besides, previous works demonstrate the effectiveness of relational information on detection tasks. However, the relation-based knowledge distillation in object detection has not been explored yet. This leads to our second contribution. We first introduced the relation-based knowledge for distillation on detection tasks. Moreover, our method is also applicable to one-stage, two-stage, and anchor-free methods. GI are adaptively selected both from the teacher and student module by General Instance Selection Module, aka GISM. Then the feature-based, relation-based, and response-based knowledge are extracted for distillation based on the selected GIs. In GISM, we calculate the L1 distance of the classification scores from student and teacher as GI scores, and preserve regression boxes with higher scores as GI boxes. To avoid losses double counting, we use the NMS algorithm to remove duplicates. After we obtain GIs, we crop the feature from the matching FPN layer according to the different size of each GI box by RI-align algorithm, which resizes GI features of different sizes to the same size and then perform distillation. The feature-based distillation loss is calculated by L2 distance. However, only performing one-to-one feature distillation is not enough to import more knowledge. Here, we use L2 distance to measure the relevance of instances and L1 distance to transfer the relation-based knowledge. As for the response-based distillation, we use label assignment function to mask the corresponding locations within GI boxes in the detection hide. Then only the GI-related areas are distilled in both classification and regression branch. In the end, we add those three types of distillation loss with the task-specific loss to form the overall loss. In COCO dataset, all student models get significant performance gains from the teacher by our method. Besides, we also demonstrate the generalization of our method by conducting experiments on different detection frameworks, heterogeneous backbones, and field classes detection. To further analyze the contribution of each type of general instances and verify the effectiveness of GISM, we separate the GI into three types of general instance: positive, semi-positive, and negatives. As shown in the table, distilling each type of the instance can all bring the performance gain to the student model, while combining all three types can achieve the best performance. When we visualize the distillation target in different iterations, we get some interesting findings. Some key characteristic patches, like the console of the microvalve, is distilled. Some confusing background areas with the discriminative semantic information are also selected for distillation, like the oven-like machine. Besides, only a subset of information-positive instances among the ground truths is chosen for distillation. In addition, with the training goes on, the focus of the distillation targets has shifted from the sample positive instances to small confusing patches, which is more similar to a human cognitive process. That's all, thank you. If you are interested in our work, please check our paper for more details and results.